Hi, everyone, and welcome. We're thrilled to have you join us today for the Transforming AI Education webinar, where we'll be exploring how universities are advancing AI research with compact, scalable, and sustainable compute solutions using the ASUS Ascent GX10. My name is Nate Snow, and I'm Global Director of NUC Business Development for ASUS, and I'll be your host for today's webinar. Quick reminders before we get started today. Please mute your microphones throughout the session to ensure that the presentation is just clear for everybody. And please feel free to ask questions. Use the questions tool that's a part of the webinar infrastructure, and we'll be answering those questions live throughout the entire session. Lastly, we'll be sharing a portion of today's presentation afterwards for your reference. The logistics out of the way, I'm privileged to introduce our first guest. Sunita Chandra Sakaran is a leading voice in advancing AI research and innovation at the University of Delaware. Sunita has been instrumental in shaping the university's approach to scalable AI infrastructure and interdisciplinary collaboration. She's driving forward projects that bridge research and education and are really driving real-world impact. So in this thought leadership discussion, Sunita is going to share insights on how universities can build sustainable AI ecosystems and the importance of accessible compute power for those researchers. And finally, what next generation of AI discovery could actually look like. So join us as we explore her perspective on the future of AI in higher education and the critical role of partnership in making this vision a reality.
My name is Sunita Chandrasekaran. I am an associate professor in the Computer and Information Sciences Department at the University of Delaware and also direct the First State AI Institute that we have recently launched. I am also the vice chair for the State of Delaware AI Commission. And my research spans predominantly on high-performance computing and my computational research programming lab. We work on traditional as well as applied computer science. We started off with looking into programming models, directive-based programming models, especially compiler work and all of that. And that led to us exploring some real-world applications in the biophysics, solar physics, plasma physics areas where codes and real-world applications that have never been sped up or never been accelerated. So we took them and we tried to modernize some of these codes and saw many times speed up. For example, there was a code on predicting chemical shift of protein structures, and they were running for hours, like 15 hours, and we were able to bring it down to about 46 seconds. We kicked off the First State AI Institute at UD. It's about two and a half months old, so we are brand new, which is making it all very exciting. And we are looking forward to exploring sciences of different fields, different disciplines across colleges and across the entire campus. So lots of fun things to do. We are super excited to use the ASUS Ascent GX10 for not only training and inferencing, but also exploring, how we can run some open source large language models on these systems, fine-tune some of these models towards specific needs of the project. We are very excited that there is such a box that can literally sit next to a desktop or a laptop, and we can build small local prototypes on a small device such as this before we are able to scale it up on large systems. And this often helps a lot because you want to test prototype, smaller projects, which is usually the case with research academic settings. And the way we are, looking into and receiving lots of case studies from across many disciplines, often it requires creating small prototypes, right? They are not ready to scale. And it becomes important that we can use systems like this, play with it and run models on it. It looks like it can handle several billions of parameter model, which is the kind of GPUs we are looking for, and build out these small prototypes before we move it to bigger clusters and throw more data sets. These kind of GPUs, like these Ascent GX10s, because especially in higher ed, there is not only research, there is also teaching, right? We would love to use this in classroom settings and probably have students SSH into some of these GPUs, but it's important to show them what they are using, and I take GPUs to classrooms to teach, and it creates that aha moment, right? And I have a course that I will teach on research software engineering in spring, and we will be soliciting case studies from our external partners and UD partners, and I can imagine about 20-25 students at different timelines, during the semester, using the GPUs to run banking data, healthcare data, or art conservation data. You never know, right? So I think this makes a difference in the higher ed especially, because it's important to run things locally before we can dream about going bigger, because you don't want to waste time and resources on a large supercomputer, but you want to test them out locally, and that's why this kind of pieces are super critical for a higher ed academic setting. In higher ed, often you don't probably have the infrastructure or the bandwidth or the cooling to put a very large system, right? And so here is where putting many of these together in a power-packed envelope, at the same time, while we have restricted budgeting, even if there is a large institute, we are working on a tight budget. So here is where, putting systems like this or GPUs like this together is already building a super powerful cluster, which is perfect for education in a university setting. Yeah, we have started to look at different types of workloads, meaning we have gotten faculty from coastal science, sport analytics, irrigation facilities, plant and soil sciences, art conservation. They all are very different workloads, right? So in that context, for example, sport analytics, we have baseball data, softball data, and we are trying to understand pitchers' performance and how to provide coaches with more data on how they can coach athletes, on pitching, for example. The other workload we will have, and I would love to throw those kind of workloads on this kind of system, is art conservation, where we have data from museums on textile, wood, canvas, etc., books. And in the very small scale project, we already identified toxic elements like arsenic and copper and mercury in some of these books, which have led to dilapidation of these materials, right? We want to preserve them. That's a goal. Now, this is not only, right now we're only working with Winterthur Museum, but imagine if this scales across the Mid-Atlantic, the Northeast, and the entire country, then you can imagine the kind of data set that we would have. Now, if we collected all of it, did some data analysis, data engineering, then this makes a perfect box for us to to process more data. Right now, we don't have the power to do that locally, right? We're just using a laptop. But having connected this to the laptop, we are able to throw more data sets on these kind of systems and explore more predictive models on how these museums can preserve their art. There is so much to do. There is so much to do. Within UD, there are plenty of things we want to do, including not just research, but also operation tasks. What if we could create chatbots to query a bunch of questions pertaining or customized to a particular operational task, right? It could be compliance regulations, it could be We write grants, and every grant has its own paperwork to follow, legal paperwork to follow. What if we used chat box to query what are the restrictions to be used and not used for a particular grant? It could be NIH, could be DoD, could be DOE, what have you. But right now it's all done very manually. And what if we automated some pieces of it, right? And what if we were able to query AI research happening on campus, AI education happening on campus, instead of sending survey forms? What if we created a chatbot, make it appear in our website and have UD community use it? So there are different ways we plan to explore these GPUs. When you talk about foundational traditional computer science, you would use an LLM and you would explore the weights and parameters, explore the model, throw data set and see how far you can go. At the same time, I think it's also critical to think about the interdisciplinary science, where you're applying several of these machine learning and deep learning skills towards a domain, a research domain, right? And that is part of the other large NSF grant that we got last year, which is Democratizing Access to Research Software Engineering, DARSI, where we collaborate with political science, coastal science, fintech science, and multiple other disciplines. And we have gotten their data set, and we are trying to see how we can apply AI to interdisciplinary science, because that helps somebody like me with a computer science background to think about what are the gaps in the field of traditional AI where we can make a difference. And I often feel like if it is driven from the interdisciplinary science, then you're working towards a problem, right? It also opens up ideas, and that makes it all very exciting for us, for professionals, and especially for our students. So I think there are, plenty of opportunities it opens up when you have something that you have access to. So the opportunities are endless. That's the long and the short of it. The AI is evolving, and there is just a lot to do. And we are constantly looking for partners to work with, collaborate with on not only hardware purchase, but software and operations, and any solutions ASUS would have that we can leverage for numerous types of workloads on campus, which involves research, education, operations, all encompassing within an ethics bubble, right? So they would love to explore how we can work more closely, because I think it's important. Thank you very much, ASUS, for giving us these Ascent GX10 units. And we cannot wait to see what kind of cool science these units can open up for us. And we're very much looking forward to it. So thank you very much.
Next presenter is Sama Bali, Senior Product Marketing Manager at NVIDIA. Sama leads the initiatives that help bring cutting-edge AI and accelerated computing technologies to researchers like Sunita, along with developers and enterprises worldwide. Today, she's going to share insights on how NVIDIA's latest platforms are empowering universities and research institutions to advance their AI research and to drive it at scale. Take it away, Sama.
Hi everybody, thank you so much for joining this webinar. My name is Sama Bali. I lead AI Solutions Product Marketing at NVIDIA. And I think everybody here will agree with me that AI is advancing at such an extraordinary pace, driven by breakthroughs in autonomous AI agents, next generation reasoning models, new scaling laws that are really transforming how we build and deploy intelligence systems as well. So let's break down each one of these. So, starting first with autonomous AI agents, which have rapidly evolved from simple rule based tools into sophisticated programs that are capable of independently handling complex projects from start to finish, which means that now you're going to see dramatically higher productivity as well as automation across industries. Next, we have got AI models that are now capable of advanced reasoning. So that means that they can reflect, self-correct, verify, plan, allowing them to really tackle much more complex tasks than ever before. all of this progress has now led to the emergence of new scaling laws. So we know that by providing more computing power, not only does that improve model training, but it also is essential during post training and especially at inference when that AI system is really thinking through and solving difficult multi step problems. So, together, these shifts are rapidly pushing the frontier of AI. They're unlocking new opportunities, new kinds of business applications, and really automating that high level decision making and laying the foundation for next generation of intelligent tools and agents. In fact, AI has rapidly evolved from a niche tool to a core necessity in higher education, transforming both classroom learning and advanced research environments. Across the globe, we are now seeing institutes are transforming education with AI, giving every learner, every student access to powerful new tools for discovery, for innovation, for hands-on experience, while researchers are pushing the boundaries of what's possible in fields like science, engineering, medicine. With scalable AI solutions, your campus can really foster real world skills, prepare students for tomorrow's careers, inspire groundbreaking research. By really investing in advanced technology, you're not just keeping pace, you're preparing your community to lead in a rapidly changing world. So, you already heard earlier about it in the session, but ASUS and NVIDIA can really help you shape the future of education, and it starts with ASUS Ascent GX10. So I'm going to use the next few minutes to really talk about the software stack that comes with GX10 because it's that hardware software combination together that makes it so powerful, especially for student learning as well as for researchers. So ASUS's GX10 comes powered with NVIDIA's GB10 super chip, and it comes pre-installed with DGX OS. So that is an optimized version of Linux so that it's easy to get started with any kinds of AI frameworks and training and tuning out of the box, along with NVIDIA AI software stack. So that means that we provide support for all of the key NVIDIA frameworks and platforms such as NVIDIA NeMo for model customization, Cosmos for physical AI application development, Metropolis for vision AI application development, Holoscan for AI sensor processing, and NVIDIA Isaac for robotics development. The NVIDIA AI platform also includes an extensive ecosystem of third-party tools, models, applications, services from partners such as Meta, OpenAI, Google, Hugging Face, and so many more. Now, students or researchers who are using ASUS GX10 can also take advantage of NVIDIA NIM microservices and Nemotron models for the GX10 platform, as well as the NVIDIA blueprints to get started with agentic AI development. With NVIDIA, building AI locally on ASUS Ascent GX10 is simple and powerful. NVIDIA NIM microservices enables you to deploy containerized AI models for reliable, high-performance production right at your device. The NVIDIA Nemotron gives you open models complete with data, recipes, making it easy to customize AI for your specific needs. And with NVIDIA NeMo, you can seamlessly manage the entire AI agent lifecycle from development to deployment and monitoring. Let's talk about each of these components now. So starting first with NVIDIA NIM microservices, which is really designed to provide ready-to-use AI models packaged in containers, making it easy to build and run powerful AI applications securely on any NVIDIA GPU-equipped system, and that includes the GB10 chip in ASUS GX10 as well. So each NIM includes the model, it includes the necessary software, optimized settings. So as somebody who's experimenting with AI models, or as a researcher who does not have a lot of time configuring or tuning things by yourself, this provides you that easy setup. All you have to do is go to build.nvidia.com, simply choose a model, download the NIM container, and start using advanced AI models in your own environment by downloading it locally on your GX10 while keeping your data, your processes, everything private on that system itself. Now, I do want to call out that if you sign up for the NVIDIA developer program, it's a simple sign up where you just provide your email address. You get access to all of the NIM containers that we have. You can look at each one of them. You can prototype on the website on build.nvidia.com. But if you are looking, you can download a bunch of these NIM containers locally onto your system and get going with your AI application development. So we just covered NVIDIA NIM microservices, which are optimized models, but let's take a step back, right? AI isn't just solved by one giant model. Every university research field faces unique challenges. In higher education and research, disciplines like biology, engineering, climate science, even the humanities, all need AI that can reason about their specific data, research questions, and workflows in very different ways. The key here becomes flexible, customizable AI that adapts to the need of researchers, educators, students, powering discovery and innovation across the academic spectrum. That's why the future isn't about a single massive model, but it's about systems of models, large models, small models, all working together, tuned and specialized for specific domains. We are seeing the rise of specialized AI because this is what is going to help researchers, students, universities really combine open foundations with their own proprietary data, and that unique data is where they unlock real differentiated value. And this is exactly the lens through which we approach Nemotron as well. So, Nemotron is not just a collection of models, it is a suite of open source AI technologies. So, that includes models, data, techniques, recipes that we, NVIDIA, openly shares with the world. So, we start by building Nemotron as the state of the art models. So, models that can reason, call tools, follow instructions, and support agentic tasks. Then we take it one step further, right? We disaggregate, break it down into open building blocks that you see in the diagram that anybody and everybody can use. So let's start first with the models. NVIDIA starts by taking these proven models such as Llama, Mistral, Qwen as a base for Nemotron's architecture. Then we enhance them with high quality synthetic data and advanced alignment techniques for stronger reasoning and efficiency. Now, Nemotron offers these models in three sizes. You've got Nano, Super, Ultra. Now, Nano offers fast inference and low memory usage. That means that it can be easily used as part of your GX10 ecosystem itself. So you can run these models, download these models, create a lot of your workflows like real-time coding, design assistance, document analysis, automation directly on your GX10 without any kind of latency issues. These models are available from Hugging Face or as a NIM container as well, available on build.nvidia.com. So researchers, developers, educators can run these models locally or even in air-gapped environments, just improving privacy and data security. Now, if you look at the diagram again on the slide, the second component here is data. So we're making our pre-training as well as a post-training data set available on Hugging Face 2. So these include domain-specific data sets for Common Crawl, math, code, fine-tuning, post-training sets, multi-model VLM data, reinforcement learning and cross-domain reasoning data sets, and even synthetic persona generation. Now, the next in this is going to be the libraries and the recipes. So this is where our expertise really comes to life. So we bundle precision algorithms, alignment methods, and scaling frameworks into our Nemo offering. And I'll talk next about that, but it essentially gives you step-by-step instructions to really create, maintain these AI agents itself. And then lastly, on this particular piece of our Nemotron family is that open research. So here you'll find projects like Mamba Plus Transformer to cut inference cost and memory overhead while keeping or improving accuracy. We also have another research called Nemotron Cortexa, which builds AI agents for software engineering tasks that can actually solve real GitHub issues. And it's again optimized for both accuracy and cost per inference. So the result is that you've got more transparency into how we build these models. So think of Nemotron really as a toolbox. It's a set of resources that anyone can use, whether you are just somebody who's just starting with a lot of your machine learning techniques, trying to build your next AI application, or somebody who's into research as well to build your own AI, tune it to your unique data and needs. So, with Nemotron, NVIDIA is actively advancing the open AI community by releasing top performing models, comprehensive data sets, and detailed agent blueprints, really empowering researchers to innovate across all kinds of fields. We've got the NVIDIA Nemotron Nano 2, which, as I said, really can easily run on GX10. It stands out as the fastest inference large language model in its class, using the hybrid transformer Mamba architecture for high reasoning accuracy and efficient throughput, making it ideal for real world research applications. Specialized tools like Llama Nemotron Vision can help process academic enterprise documents. Nemo Retriever streamlines RAG for research knowledge management, while Canary and Parakeet advance spoken language research, and Co-opt optimizes workflows like equipment scheduling and logistics. We are also opening up the datasets used for training of our open models, and the Nemotron post-training dataset is, as you can see, trending on Hugging Face. Additionally, we've got the NVIDIA IQ Blueprint, which has enabled an open research agent to recently achieve a leading score on Deep Research Bench, just showing how accessible tools and models can help drive state-of-the-art research progress. Okay, moving next to NVIDIA Nemo platform, and I mentioned this before, this is really designed to help you build and manage different kinds of AI agents. And this is especially impactful for higher education and research, as it streamlines every step of that AI agent lifecycle for universities and research labs. So it comes with a bunch of things, starting first with Nemo Curator, which accelerates the processing and curation of vast academic data sets, helping faculty, researchers really prepare data for specialized model training and research projects. Next, you've got Nemo Customizer, which allows researchers, educators to again tailor AI models using institutional or research specific data sets, supporting the development of domain adapted agents for scientific discovery and instructional tools. Post that, you've got Nemo Evaluator, which rigorously tests, validates customized models to ensure they meet high standards for accuracy, reproducibility, academic benchmarks. After that, we've got Nemo Guardrails, which enforces ethical, privacy, institutional guidelines, helping universities and institutes maintain compliance and responsible AI use in research and educational settings. And then lastly, you've got Nemo Retriever, which connects AI models to campus databases, online repositories, really helping enable real-time information retrieval for literature review, knowledge exploration, and classroom instruction. So this platform enables continuous improvement with AI feedback cycles that refine agents over time, helping accelerate research breakthroughs, improve teaching, and supporting responsible AI innovation in the academic community. So we just went over all of the components behind building agentic AI applications effectively with NVIDIA AI software stack. But I also want to take a moment to talk about NVIDIA CUDA-X libraries. This is a robust set of over 400 GPU optimized tools designed to accelerate complex computations at every stage of the research process. So these libraries help researchers analyze massive data sets, run simulations, and accelerate machine learning and deep learning applications, all leading to fast experimentation and innovation. I'll not talk about all 400 libraries, but let me talk to you about a few of these, starting first with cuDNN. This powers state-of-the-art deep learning frameworks for rapid model training, while we've got Modulus, which enables AI-driven physics simulations, which are crucial for computational science and engineering. We also have tools like Parabricks, which is really transforming high-throughput gene sequencing analysis in genomics. We've got Co-opt, which delivers real-time optimization for logistics and operational research. We also have specialized libraries like QQuantum and QPQC, which are driving breakthroughs in quantum computing, post-quantum cryptography, in academic environments as well. So together, these CUDAX libraries really provide the foundation for GPU accelerated innovation in research, helping scientists, researchers, practitioners push the boundaries of what's possible across disciplines. So we spoke a lot about the frameworks, libraries, platforms from NVIDIA, but let's talk about what use cases can it be used. So the ASUS Ascent GX10, powered by NVIDIA's GB10 superchip and the software stack, is really designed to supercharge all kinds of AI and data science workloads for faculty, researchers, grad students, data science learners, and what you can really do is get started with all kinds of AI and data science workflows. So, if you're a researcher, you can easily experiment, prototype new models, accelerate fine tuning, run local inference for testing, evaluation, or even building campus specific AI tools such as chatbots or coding co-pilots. Students and data scientists also benefit from the full NVIDIA CUDA libraries for hands on learning, advancing data science workflows directly at their desk. Now, the system is equipped for cutting edge curriculum and interdisciplinary research as well. So, that includes everything from robotics, computer vision, generative models, and more that can be developed and deployed with that integrated NVIDIA AI frameworks and APIs, including Isaac and Metropolis for edge computing, research centers, and innovation labs. So, any user doing any kind of AI, data science development work can use GX10 right at their desk. This can be as is, like the system as is connected to a monitor, keyboard, mouse, or they can complement their current hardware, offload their laptop, their PC, their desktop system when they need to work with larger AI models or need access to the entire NVIDIA AI software stack. So, to get started with a lot of these workflows, I am going to give you another resource known as playbooks. So, these are detailed instructions to set up and run popular workflows. These are available and cover a wide range of topics such as how to fine tune using Llama Factory or build a specialized vision language model for analyzing X rays. All of these tools are designed to really help you get started on your AI journey on GX10. So the website to visit is build.nvidia.com/spark. This is where students, educators, researchers can go to find instructions, right? We've got examples to really help you customize, run a lot of these AI workloads on GX10. You can also learn about the latest AI tools from our ecosystem, such as Comfy UI or Llama, or set up a VS coding environment directly on your GX10. So, again, visit the website. It gets you a lot of these workflows for you to get started with that AI journey on GX10.
By bringing that data center grade AI performance into a compact desktop, we're letting universities run AI workloads locally instead of relying on shared clusters or cloud services. And this eliminates hourly GPU charges and also reduces energy consumption by up to 60% when compared to legacy servers that are also running these types of workloads. Overall, moving workloads onto GX10 systems can cut compute costs by 30 to 50%, lowering the total cost of ownership while also giving students and researchers fast, dedicated access to AI resources. And by running these resources locally versus up in the cloud, the GX10 enables tighter security controls for that sensitive data and also lower latency when driving that research. And this addresses those privacy concerns and really just accelerates their progress. The Ascent GX10 is going to come in a variety of storage options. It's available now in 1 TB, and we'll also have 2 TB and 4 TB options coming shortly. And this supports the variety of data footprints that you may need to train and optimize your models. When more performance is required, the GX10 is scalable. By utilizing a ConnectX-7 cable, you can connect two GX10s together, doubling the memory footprint, enabling you to utilize even larger models. basically creating your own personal AI developer cluster by scaling the performance, doubling the memory, doubling the storage to support larger workloads. And this makes it really an ideal platform for AI researchers because they can easily deploy and then scale their solutions as they need for those larger workloads. And because the Ascent GX10 utilizes NVIDIA's AI software stack that Sama mentioned earlier, you get a common development environment that scales across a broad selection of ASUS NVIDIA-based devices. From the Ascent GX10 to powerful RTX Pro ASUS workstations and the upcoming ASUS Expert Center Pro that'll utilize the GB300 superchip from NVIDIA, and even up from there into the AI server realm, where we see the ASUS AI Pod also utilizing that GB300 superchip. So a whole ecosystem that's utilizing that common set of software tools. Before we wrap up today, we know that this is only the beginning part of your AI journey. And so here we've captured some of the key resources so that you can continue exploring and discovering on your own. First are some links to the product pages where you can dive deeper to learn more on the details of the Ascent GX10 or get a sneak preview of that Expert Center Pro that will be coming in early 2026. Also, make sure to check out the resources that Sama mentioned earlier on build.nvidia.com/spark. It includes NIMs, blueprints, and playbooks that are available for the Ascent GX10. For those of you that are looking to purchase an Ascent GX10, it's available now from a variety of our partners in the US and Canada. So you can use these links to connect directly, or you can reach out to us, and I'll talk more about that shortly. The Ascent again comes in 1 terabyte options available now, with 2 terabyte and 4 terabyte options coming available at the end of November. Now, for some of you, you may be looking to test or try a GX10 before making a purchase decision. And to enable this early evaluation, we've created the ASUS Virtual Lab. Through the Virtual Lab, you can sign up to get a 72-hour, 3-day evaluation period to test your workloads on the Ascent GX10. We have support for both standalone and dual device cluster that I mentioned earlier. And during those 72 hours, you have your own private access to the GX10 to test your workloads and try out the capabilities of the GX10 device. Now, space in the virtual lab is very limited, so scan the QR code below, complete the form, and we'll follow up with you on the next steps about timing of availability. Finally, as a special thank you for joining us today, we're excited to announce an exclusive giveaway opportunity. Attendees will have a chance to win a premium 31.5-inch ASUS ProArt OLED display. This is really designed for creators and researchers who demand exceptional color accuracy. And along with that display, you'll also win the ASUS Ascent GX10 AI supercomputer. So don't miss out on this chance. You get a chance to take home this incredible tool for education and creativity. So please fill out the survey, and winners will be announced and contacted by December 12th. Thanks again for joining us today for these insights into how AI is transforming and accelerating research and education. If you have additional questions or want to learn more, you can reach an ASUS sales contact via the QR codes shown here. As I mentioned earlier, we'll be making the slides available, so all the links and QR codes you'll have offline for your reference. And we want your feedback. We want to hear from you on what you want to hear from ASUS and NVIDIA and our partners about how AI continues to evolve and the future and trends, and how ASUS is supporting those innovations. So please fill out the survey. This concludes our webinar for today. Thanks again for joining, and have a great day.